So now we'll have a look at the different layers in the single user operating system, and the first one is the CLI, the Command Language Interpreter, and this is the layer that the user would interact with to give instructions to the computer. Now some of you might remember older computer systems that are command driven. You might remember the black screen. That was the DOS window. It was a disk operating system, and it was so that you could type, or you had to type in all your instructions. It was before we got HCI and WIMP and GUI in our menu driven system, where we used the mouse to select icons and so on. And this layer's job, is to make sense of the commands the user's trying to do. So if, for instance, you wanted to open a file, then the CLI would interpret and understand and make sense of that instruction, where you maybe click file save or you double click on a file location, and it would then pass that information on to the next layer, which is the file management system. Now the file management system has a table of the precise physical locations of where every file is saved on disks. If you think of Tesco, of record stores, they'll have a precise location where everything's saved, and it's one of the ways that things can be messed up in a file. If this hashing table is messed up, the addresses are in it. Things it saves in this hashing table are the file name, who created it, the last date it's been edited, the file type, whatever file it defaults to open with, and so on. And because it holds the precise physical locations, after you click on a file and the command language interpreter responds to that, it would pass on that you're trying to open a certain file to the file management system, and its job is to look up and find the exact address of the files or where they're saved on disk, so that it can be found by the input-output layer eventually, so that it can open them. And it uses a hierarchical filing structure the way we see it. And if you look, this is a terrible diagram of our RM shared area, where we have separate folders, and they're organised into folders containing other subfolders. Now there should actually be an arrow between computing here that's missing, and you can see that this is us browsing down computing and then into the higher subfolder, and then you can see the different subfolders in the higher. But that's not how it's stored by the file management system. That's how we see it. It saves every precise physical location. So a wee reminder there, it stores files in separate directories and subdirectories to organise files. So you have folders of your images together, folders of your videos together, and so on. And it's much easier to organise our files that way, to keep everything organised and keep everything that goes together in the same place. The next layer is the Memory Management System, MMS, and this job is to keep track of the state that memory's in, the main memory or RAM memory's in, and it keeps track of things like how much memory is available total, what programs are currently loaded, and how much RAM that is currently available for other programs to load. And it allows programs to be loaded and so on. Now if there's only so much RAM available in your computer system, your operating system is going to be taking up some of that. Every time you load a new program, then it's going to start taking up more RAM memory. And when you double click a file to load it, that's obviously going to be loaded at the processor and stored in RAM, or an image or so on, whatever you're trying to load or try to send out is going to be in memory. If there's not enough memory in the memory management system, would flag that up, and it may send an error message back through the CLI to tell you to close other programs down, or it's going to ensure that there's a fair share of processor time dealt out to each different operation you're trying to do. Okay, so questions that will come up: why is a crash more likely on a disk-based operating system than a ROM-based operating system? And that's because disk-based ones are likely to crash. And have a wee bit of research to do. Why does the reset line help avoid damage to other parts of the computer system? Last two layers then, input-output management. Input-output management, it communicates directly with the peripherals. and so is responsible for the transfer of data between peripherals and the processor and vice versa. So it's quite a straightforward one to remember. And finally, you've got the kernel, which is responsible for managing the processes and handling any interrupts that may appear as a result of errors, etc.